unloading data using map function from onto the dataset graph. This is how we are going to deal with it. So tf.dataset, so tr images with map, then we define so that lambda is x, since we saw that in our data set right now we have only a tensor of type string, so that's why it's lambda x only. If it was a tensor of lists, or rather tensor of vectors, then we would have put maybe x, y, maybe two the vectors, or x, y, z, a vector of three values. But since it's one, which is say lambda x, then we actually have to wrap the function that we're going to use in a pi function in order to be used in the computational graph. So function is read inputs. The inputs are for now x, and training whether it's true or false. So for the training data set it should be true, so hence that's why. Then the output, so this one, the first one is the output for the image, this one. Then the second one, the type, I would still want it to be float of 32 bits. So it will be automatically cast to this data types. So then I'm going to use the optimization algorithm to tune it. Yes, so this is for the test. Then for the train, this way. So yes, it will be the same, except now it will be false. So now if we run it, let's say for I in, now this one actually the inputs will be true for the train dataset. So I'll have to do that one. So let us just get to view the use one, view what we have. So when we run it, what is the problem here? It has an attribute CVT color. So we had a typo here. Going to correct and run it again. So we have the image and the tensor. So what I can do is introduce a batch. Actually, so I did not define the batch size in the configuration, which I'll just have to do. I'll have to make it 15. So let me just let me just run everything again. So allow me to pause it and run it again. Yeah, so we have added the batch size to the default config. Now I've run it again because the train images were the tf.dataset format, and so that's why the error, but now it's okay. So I had to rerun the previous cells, and now if define batch size for both train and test. And so if I run this one, it will be batch size of 16. Yeah, so we see that the images are 16 of size 300 by 300 RGB. Then we have the whether it's a cat or a dog. And then if we view for the test, so if I leave this one for the test, it will give me an error because the test is actually having one output, not two. Hence why. Yes, so running the text returns one well. So let me look into the error. So the issue was actually here. Since for the test we have only one output, it should be this way. Yeah. So if we run it now, it will be okay. So now for the test, it actually has only one output, which is different from the way the train is that has two outputs in the batch. So the first way, this one loads the whole data into the computational graph. Let me show you the second way, which you ought to use since it loads in batches to the computational graph, hence does not actually overload the memory during training. So let me just paste the code for loading in batches to the computational graph, since I already talked about it in detail in my previous video regarding training on tf.data.Dataset. dataset. It is one of my first videos, so you can refer to that in my YouTube channel. But anyway, this is the code. So let me just explain it a bit. So you have to redo these ones, since this one was already in the tf.data.Dataset format. So you have to do this one, since this one is now a different way of loading in batches to the computational graph. You have to do this one, then also this one, then so we create a function called known as create dataset, and then we define the generator which will take the paths, then extract the image and labels or image itself regarding whether the training is true or false. Then after that, the generator yields the outputs to now the tf.data.Dataset from generator function, which will now get to create our computational graph with output signature either being image and label. So this is the image and label, or if it's image alone, we just have to define the output signature for the image alone. But for the train, we have to define the output signature of the image and label. So yeah, and then after that we return the data after batching it back to the caller. So in this case now, when we call the functions, so here create dataset, we pass the train images. This is the batch size that we'll be using. This is the whether train is true or false. So this is create dataset. So in case maybe this one is 8, then when I run it, now I say for x, y to train data.step1 shape shape. So if I run it for the trained gen data, I get 8 images of 300 by 300 RGB. Then the test is 8 by 2. And then for the test gen, which is using the 16 batch size of the configuration, if I run it, oh yeah, now it's because it's returning only one output. There's no need for the second part. Yes, so we see as two methods of loading data to the computational graph, as a whole or in batches. So you use either, but the second is efficient over the first one, since there's no memory overload or memory usage in caching the data during training. So yeah, so right now we are finished with this step. We are going over to the next step.